class. You are on to my YouTube channel. I'm your favorite teacher of chemistry, teacher Odume Lovett. Now, today's topic, we are going to do some calculations based on Faraday's first law of what? Electrolysis. And now this calculation will be based on what? Electrolysis too. Knowing that electrolysis is the chemical decomposition of what? Substance by passing electricity through what? Heat. Then under this electrolysis, we have two important things: the electrode and what? The electrolytes. Under the electrode, we have what? The anode and the cathode. The anode and the cathode makes up what? The electrode. Now again, this electrode we're talking about now, the anode, is the positive electrode through which the current enters what? The electrolytes. Oxidation reaction occurs at what? The anode. The anode is the positive what? Electrode through which current enters what? The electrolyte. Oxidation reaction occurs at what? The anode. While the cathode is the negative electrode through which the current now that enters that electrolyte leaves what? The electrolyte. Reduction reaction occurs at what? The cathode. Now, coming to this equation, we know that the Faraday's first law of electrolysis, that it states that the amount of a substance liberated during electrolysis is directly proportional to the quantity of what? Current passing through it. And 1 Faraday is given as 96500 coulomb. It's like a constant. From this calculation, determine how many moles of electrons are transferred when 4825 coulomb of electricity are passed through an electrolytic cell. It's going to be like going from the known to what? The unknown. Starting for example, solution. So if 1 Faraday liberates 1 mole of electron, therefore we have that 1 Faraday is equals to 96500 times 1. That will become what? 96500 coulomb. Now we have it that 1 Faraday is equals to 1 mole of electrons. Then this becomes what? 96500 coulomb. To give you 1 mole of electrons. Therefore, how many columns are you to here? We are giving what? 4825 columns. Therefore, 4825 column will liberate X mole of electron. So X mole of electron, when you cross multiply and make it such a formula, now becomes, take this to this multiply this across now, that is to cross multiplication. 4825 times 1 mole of electron. Divided by this, making a set of what? Formula. To make some sort of formula, I have to divide by what? The 1 Faraday. So we now have the answer as 0.05 moles of electrons. So that is the answer for the question. We have another question again. Christiana. Now, the second question is, how many Faraday of electricity are required to deposit 0.20 mole of what? Nickel. If 0.10 Faraday of electricity deposited 2.98 gram of nickel, during the electrolysis of its aqueous solution. Now, it looks somehow complicated, but it is not what? Complicated. The only thing now is that the mole was not given to us. But since the relative atomic mass is given, we can now equate it to get our mole. First and foremost, we'll now look at mole of nickel. We have it as mass and relative molecular mass. We now have this one as 2.98 gram all over. The relative atomic mass is what? 59. So this will give us if you divide it, now give us 0.05. Mole. So the number of mole of a nickel that was liberated is what? For the calculation, 0.054 mole of what? Nickel. We're like, okay, let's continue now. 1 Faraday will liberate, if this number amount of Faraday liberates this now, 1 mole of electron. Now we have this at the given Faraday as 0.10 Faraday. That will give us what? This number of mole, 0.05 mole of electron. Therefore, we are asked to look for the number of, the number of what? Faraday. That is the amount of Faraday to deposit this mole now. The X Faraday to deposit this mole electron. We have to cross multiply again, take this to this, and take this to this. Now make this sort of what? Formula. S Faraday will be equals to 0.10 times 0.20 all over 0.0505. So now, our number of Faraday, if we equate it, it will become 0.40 Faraday. Again, we have again will be a current of 0.02 amp silver, Now, look at another question again based on Faraday's first law of electrolysis. This question you always see it in every examination. Calculate that a current of 0.0 amp flow through a silver triosonite 5 solution during electrolytic process that lasted for 30 minutes. Calculate the mass of silver deposited. Now, in this situation, it looks somehow complex. What should I see? I've seen that there's minutes here, there's current, there is a molar mass, there is this. No. Don't be afraid. There is an easy way to this. Just close your eye, bam, you have done it. Very simple. But I'll give you what? The recipe. Look at it here. There is a formula that I've gotten as, if you are using this, the mass, you have to know the reaction force. The number of electrons times 1 Faraday equals to current times time times relative times atomic mass of that substance. Now we are asked to look for the mass. So we are going to make this one set of formula. Then how do we get the number of what? Electrons. Then for silver, you know, is a monovalent. This is silver here plus to begin to liberate was silver solid here. This is aqueous. This is aqueous. So the number of electrons we have there is what? 1. Assuming that it is copper 2, the number of electrons becomes what? 2. Assuming that we ask for aluminium, you know that aluminium is a trivalent and it's going to be what? 3. The number of electrons becomes what? 3. Assuming that is oxygen that is there. Remember that during electrolysis of water, acidified water, using Hoffman photometer, and the electrolyte was what? Dilute H2SO4. Oxygen was what? Liberated. It was oxygen that was discharged at what? The anode. And if you watch it, it was 4 electrons. Why 4 electrons? Oxygen is what? A divalent and diatomic what? Molecule. That gives it what? That 4 what? Electrons to be discharged. Now looking at this, we have it this now as 1 electrons. Make this mass your solid of what? Formula. I come again. The formula is what? Mass times number of electrons times 1 Faraday. And 1 Faraday is what? 96500 coulomb. Equals to the current times time times atomic mass. At times, the quantity of charge will be given to you in coulombs. Thereby, that means the current and time have been given to you already. So mass will be equals to, so number of electrons is equals to 1. Current times time times atomic mass all over number of electrons times 1 Faraday. Now, another thing again, look at the time here is in minutes. Students, always check. Assuming that it's in hours, you have to convert them to seconds. So converting minutes to seconds, you multiply by what? 60. Then if you have to convert an hour to seconds, becomes 60 times what? 60. But here we have minutes. Right. So the current here is what? 0.02. And what is the time? 30 minutes. If you are converting, it becomes what? 30 times 60. What is the atomic mass of silver? 108. Number of electrons is what? 1 times 1 Faraday, 96500. So mass of silver now becomes 0.40 gram of silver liberated during the electrolysis. Please subscribe my channel and God bless you.